Welcome everybody. Thanks a lot, Alexander, for the introduction. I will just give a short introduction on the webinar of today to give a little bit background on the global framework where this webinar fits in. So it's one of the outreach activities of Annex 58. Annex 58 is a research project from the International Energy Agency, the Energy in Buildings and Communities program. And it's dealing with reliable building energy performance characterization based on full-scale dynamic measurements. So you see there the on-site energy performance characterization is one of the key topics, and that is also one of the topics we try to deal with Coheating Test. This is combined with DYNASTEE. You see the DYNASTEE logo there. We work with, in Annex 58, closely together with DYNASTEE. I will come back to that later on. Just a short background on the research project. What you see here is some examples of how we nowadays try to characterize or try to predict the energy performance of buildings, ranging from very simple, almost quasi-stationary programs as we use, for instance, in Europe for the EPBD regulation, going to very advanced simulation models, what we call building energy simulation models, who try to deal with all the parameters and all the information we have to predict the energy performance of buildings. And based on that, we try to give a certain outcome on what is the quality of the building. We label them, we give them green or red signs, we certify them, we give them stars and all kind of labels. But several studies have shown that the actual thermal performance of buildings after construction may deviate significantly from that what we predict at the design stage. This is a graph that some of you are probably familiar with, but it's a very good introduction for today. It gives some results from measurements done by Leeds Metropolitan University, looking at the overall heat loss of buildings. And you see in blue the measured heat loss coefficient, and in purple the predicted one. And you see that the deviations can be quite huge. And so for us, it's rather clear we do need on-site testing. That is the only way to characterize the actual performance of buildings, and in the end, that is what matters and not what we fill out on paper based on the design. So that's the global aim and the objective of Annex 58 research project of the International Energy Agency. So we try to characterize the building energy performance based on on-site full-scale dynamic measurements. And some of the objectives more in detail, it's determine the actual energy performance, but also characterize dynamic behavior of buildings with what we call gray box models. So we try, based on the measured data, we try to simulate the behavior of the building with rather simplified models, but perhaps even more reliable than some of our very advanced models. At the same time, what we have also done within Annex 58 is we did a very detailed experiment, full-scale experiment on a building, and we use this data to validate our numerical building energy simulation models with. And what we are quite well aware of is that to do reliable measurements and to do a reliable data analysis and to do or make a reliable use of the results, we have to be able that we can guarantee the quality of both the measurements as well as the data analysis and the correct use of the results. And that's also one of the very important topics within the project. The focus of the research project is, on the one hand, a characterization of what we call the building fabric. So we look at the U value, thermal resistance of the building components, the overall heat loss coefficient, the G values of the window. And then on the other hand, we try to characterize the overall energy performance of the building. So it's actually ranging from quasi-static tests towards dynamic characterization based on the measured dynamic data. And we are quite well aware that certainly when you look at the global building energy characterization, the impact of the users is very important, as is the impact of the building system. But we don't really focus on those topics that we don't look at what is the impact, but we mainly look at the overall characterization of the fabric and on the other hand of the whole building. And the webinar of today is dealing with coheating test, and that is one of the topics where we had quite some discussion on and progress on in Annex 58. That's related to the building fabric characterization. We try to determine the overall heat loss coefficient of a building based on on-site measurements. A few words also on DYNASTEE. So we work closely together with DYNASTEE. DYNASTEE stands for Dynamic Analysis, Simulation and Testing Applied to Energy and Environmental Performance of Buildings. You see the link to the website of DYNASTEE. And together with DYNASTEE, we try to disseminate some of the results and the research we are doing within Annex 58. So it's a close interaction with the target groups at different levels. We do that via the website, via reports, via a regular newsletter. There's a training for, let's say, advanced researcher. There's a summer school on dynamic analysis methods. We had one 2 years ago in Denmark, last year in Spain, and this year we will have one in Belgium in September 2014. And as a kind of follow-up of this webinar on coheating, there will be a more extended live workshop in Ghent this year related to on-site characterization of overall heat loss coefficient, but also looking at the more global dynamic characterization. And then in the end, or in autumn this year, there will be a second workshop or next follow-up in Berkeley, United States. For today, so we focus on building characterization by coheating, and I think we have some very good speakers there. We start with a team which is very familiar with coheating tests. That are the people from Leeds Metropolitan University, which have quite a lot of experience with coheating in the UK and performed a lot of coheating tests there, and who also were able to determine this gap between actual performance and design performance. And then we give the floor to Geert Bouwens, PhD student here at the Building Physics section in Leuven, who will give a more global overview of the coheating test methodology and what is behind this methodology and how can we improve accuracy of coheating tests. And then Guillaume Pondreau from Isover France, we give a presentation on a kind of alternative for the coheating test, which is called the cup method. So I propose to start, and I hope you will all enjoy this webinar. But I will first give the floor back to Alexander to explain you how you can ask questions in this seminar.